I think yesterday we have discussed about uh, what we discussed software management, right? I mean, how to install any anything in Linux machines, any packages. So usually we can call it software also, I mean, which is fine. But we just call it packages because that's how it is in Linux. I mean, that's how the terminology is, as well as that's how it looks like as a package. We call it a software. Let's say Chrome software. It's fine. Complete that is also fine. But in Linux, the format it does not comes as like an .exe. There are no exceptions. That's why we call it a package. So today we'll talk about few more things, small, basic ones. First thing is service management. Service management is like I have installed the software now. Let's say anything. Let's take SSH as an example, since we already have it. I want to manage the service. See what you can do with the service. You can start a service, stop it. You can manage it, right? You can start, stop, restart, reload, check the status, disable it, enable it. These kind of things. So any service, take it. Let's say anything I'm telling you. So SSH is one example because we are using it. There will be few more things, in upcoming classes. But so yeah, what can we do with this service? That's we'll do today. Just few commands only. Let's say I'll install one thing. Install Nginx. Forget about what is this thing, but I'm trying to show you example of a service. I mean, how to manage the service. That's it. What does the service do? That's a different topic that we don't need now. So now we have one service called Nginx. First we'll see is uh, service is installed, which is fine. We can able to use with yum, right? Yeah, we can able to filter out with yum commands or apt commands, as I told you yesterday, whether it is installed or not, like that. So now to manage the service, we have something called systemctl. 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 This is common command everywhere in Windows. Sorry, in Linux, like Red Hat, Ubuntu. Everywhere it's same command. No changes. Except the installation command is different. That's the only thing. The systemctl is normal everywhere. So there are multiple commands, with the systemctl. This is to manage the services. The first command is status. Systemctl status. What status you want to check? Let's execute this. If you observe, I just executed systemctl status. You know what it's showing me? It is showing me all the services which are running currently in the machine, in this system, in the server. See, all, even this the new one which is installed. See, systemctl status, which will show all the running services, whatever the active currently running or active, both are, so it will show like green. See, so many are there. Instead of this, I want to see a particular service, whether it is I want to manage a particular thing, I want to see the status of a particular service. Just give the service name. Let our service name is Nginx. So it is showing you whether it is active, running or not. Since Friday, blah blah blah. The timing, UTC timing, 1 minute 56 seconds ago. Like that, it will show you status. We can do anything. We can start it. Of course, it's already running, but yeah, we can start it. Nothing will happen. It will be running anyway. Let's stop it and start it again. Systemctl stop. Same thing. Systemctl, the command, the action, the service. What actions we have? We have seen status, to check the status. Start, of course. Stop, we have seen. Now let's check the status again. Why? Because we have stopped it, right? See, inactive, dead. The service is stopped. It means, as I told you earlier, whenever For everything there is a process running in the background, right? That process has been stopped when we stopped the service. The process which belongs to this something called service called Nginx, that is stopped internally. So that's why it is stopped. Start again now. Systemctl start Nginx. There won't be any output obviously. If there is no output, it's success. If there is output, it is failure or something. It will show you. Now check the status again. Active running. See, name, all these things. It's easy, right? Just start and stop. Now we have something called reload. Sorry, restart. Let's start with restart. Obviously, you know what is restart. It's restarted 4 seconds ago. It's restarted. Earlier it was 8 seconds ago. Restarted. You know what is restarted? Start and stop. Stop and start. Sorry. So that's it. There is something called reload also. Reload. What is this reload is? Usually restart, what happens is, let's say you restart your phone, what happens? It will complete stop and start again, right? It will shut down your phone and it will start again freshly. That's the restart. Same here also. When you restart a service, it will stop the whole process, whole service, no matter how many processes are running behind it, maybe 100 or 200, it will stop all of them and start again freshly. Which will, of course, there will be a, like, let's say if the service is being used by someone else, they will see a downtime. They'll say service is not working until it's restarted. It will throw error. Obviously, it's down or something like that. But reload, let's say we don't want to restart the service, but we need to refresh it. Why I need to refresh? Like kind of, I made some changes to the configuration of the service. This Nginx service is there. There is a configuration file. Forget about what it is. So in the configuration file, I made some changes. You remember in SSH topic, we made some changes in configuration file, right? SSH or so config. And what we did after that, we restarted it. So no need to restart over there. We simply reload it. What we do when we reload, systemctl reload SSHD also, what happens is, it won't restart the service, but it will reload the configuration. It means it will take the latest configuration, whatever we have updated, without restarting the whole thing, whole service. Got it? That's how the reload works. Reload, nothing, no output, obviously, because success, no output. If it is a failure, there will be an output. Now there is two more commands. Systemctl enable service name. What's happening here is, enable means, start means, okay, start the service, obviously, which we know it. Stop. What is enable then? See, usually what happens when you restart your server, this service won't start by default unless you enable it. If you enable, what we are doing is, you are enabling this service to start at the time of booting. Booting means at the time of starting the machine. That's what you're doing with enable. If you don't want to start this service at the time of booting, you disable it. Yes, disable it. So you disable it. So now what happens? See, earlier it was enabled. Observe here. Service enabled, now disabled. What happens is, now when your Linux server is restarted, this service won't start automatically after the restart happened. After the restart finishes, you have to start it manually. Systemctl start, blah blah blah. So mostly we enable it. Why? Because if it is needed, if it is required to run, so when we restart the server, if we enable it, once the restart is finished, at the time of restart only, mostly at the end of the restart, it will start all the services whichever are enabled. So that's what Linux does. Got it? So that's why if it is required, we will enable it. Got it? We can check also. Check whether service is enabled or not. Sorry. How to check? Systemctl is enabled. This is a service name Nginx. Sorry. Is sorry, is enabled. See, enabled. We can just check, I mean, if it is enabled or not, or you can do systemctl status service name also, which will show you by default. Whatever it is, fine. That's fine. That's it. These are the commands. In service manager, how to manage the service. But the main thing here is how we are managing these things. I mean, of course, by executing a command, will it work? Is it managing the service directly? If you take any command, so for any command, starting from basics, ls, cd, something, unless apt, all these are, as I told you, there are executable files for them in bin or sbin. Let's say which apt. So user bin apt. Here what's happening is when you execute a command called apt, it will execute this file, this script, let's say, to be honest, or like that. This script, what happens is, which will which will get executed whatever the content, I mean, whatever the logic inside that file. Based on that, it will be, work. The command will work like that. If this the script, let's say, uh, have something called if the user gives apt install some package name, install that, download that from somewhere, install that, like if remove it, like that. That logic will be present in this executable file. I mean, it's not a script directly, we cannot see it. Why? Because it's packed, it's built. The script written, the logic written, and it's built, and the executable whatever came out after the build, we are using that. So let's say your phone is there. I mean, I'm just giving you a small example. It's running on Linux. That does not mean you access the Linux, right, in your phone, correct? Your phone is an Android. How come? See, this Android is using the Linux, internally. That's fine. That's not related for us. Android software, how you are using it? It's built. What you see when you buy a phone, all these pre-installed apps will come to you. How? They build the OS. They build the OS, and whatever the apps you're saying, whatever the other things, default things you're saying, they kept everything in that build, and they're installed in a phone, and they gave it to you. Similar way, like here also, any command in Linux, any command, take any command. Systemctl also, which systemctl. So there will be an executable file. Executable file, where it came from? It came from a build. I mean, they have the code, logic, and everything. They build the logic. So they got an executable file. How they build it? There are a few tools to build it. We can also build like that if we know, pure Linux core developer. We can also build by ourselves. That's completely fine. We can create a new command also. So every command what we execute, it has a build. I mean, executable file .exe file. You can say it like that, but don't say it. But yeah, executable file means .exe. Even .exe means in Windows it's executable. That's the full form of it. So executable file means where we can able to execute it, where it executes and gives something, return to us. That's what executable file means. And yeah, sorry, coming to here. So every command, as I mentioned, right, it executes based on an executable file. Okay, that is fine. What's does okay now systemctl, let's say this is coming from a executable file, and this is arguments which we are passing to this apt install something means the install and the whatever we are doing, those are all arguments or parameters we are passing to the command, to this command. Same thing for systemctl, something like that. Why I am saying all this is to understand how it works. We don't touch all those things. We don't delete or we don't edit the executable file of user bin, this systemctl file, because we cannot do anything about it. If it is not working, we cannot do anything. There might be a fix, but it won't be easy because it's built. We cannot touch the build. But yeah, that's fine. That's fine. So now, similar way, uh, systemctl coming here, we are telling to enable or disable or start, stop, restart, like that. How it's taking is same thing. Executable file is there, it will take it, and How these restarts and all happening is, there are something called files. If you might have observed it, see these files. There are files where it will control whether restart, start, stop, and all. Systemctl is controlled by Linux executables because that's a Linux command. But the action start, stop, and all controlled by these files. Usually, this is the latest path. User lib system d system. Let's go there. See, so many dot service, so many are there. We don't use others, but yeah, there will be SSH also by default. It's already installed. We have to figure it out where it is. See, the so many services are there. See, our Nginx also will be there, but you have to, where is mn, right? Where is, yeah, see, like that dot service, observe here. Forget out what are all these dot service is there. See, the actions, see cron dot service also. The actions controlled by these service files. These are files, open it. See, this is a script. These are all what we do. That's it. If we start it, it is executing this command. If we, see, reload, it's executing this reload. Stop, it's doing like this. Restart means start and stop, obviously, so it will do both. So based on this script, it is doing it. We can also create a script like that, and if we know it, so we can work on it. That's completely fine. So what I want to show you, like the actions controlled by file, which will show when we do status also. That it will be loaded. See here, loaded. This, it is showing this file means the file is loaded and it's being read by the systemctl to start, stop, restart, whatever it is. Because with the systemctl we are managing a service, and the service have configuration. This is not a configuration file. You can say executable file also, or anything service file. You can simply say it service file. For every service there will be a file like this. When we install. And of course, by default, they're all stored in user lib system only. There is no different path. Got it? So with systemctl, we're controlling the services, and service have service file which will execute the script whenever we execute the commands and the things what we execute. Got it? That's about service management. Those are the only command we have. Status, start, stop, restart, reload, enable, disable, and what else? Check whether it is enabled or not. I think that's the only thing. Systemctl command is same everywhere. So hope that's clear. So before moving to another topic, we have small topics, two more topics, so that we'll close the call for today. Anything, any doubts you have? Anything? All right. We'll go to next topic then. Next topic is simple. Just two commands are there, maybe two or three. It's not a topic actually, just commands. So you have how to zip a folder in Linux. Zip me, send me a zip file. Generally, what you do is select all the files what you want in Windows and right click on it, convert to. There will be add to zip like that, or use open source one, that WinRAR software. It's easy. Similar way, in Linux also there is a zip command, or there is a tar command which we most commonly use. Zip also there, but not really much. But tar command which will be using. Tar also what we'll do is, it's extension actually. So it's a command. What we do is create .tar files and compress those tar files. Compress of it means zip, obviously. So this is one of the formats in Linux we use it actually. Tar dot tar extension will be dot tar for the files. Let's say I want to tar, it's like a zip only, simple. Create a zip file, but in Linux format dot tar, that's it. I want to let's say all these things I want to tar them. If someone has like give me a zip file in Linux, just simple use a tar command, that's it. Simple commands. Hyphen cvf. C means create, obviously. V means verbose, and F is file. Create V means verbose means it will show you what it's doing. We will see that. And F means file. So obviously we are creating a tar file, so that's fine. Here what file we are creating? Tar file, maybe test.tar. That's file. This is the file we are creating. It means imagine this as a zip file. Test.tar zip file I am creating. What should be there inside this? Now give it. Test folder I want 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the files I want. So all these data will be packed and stored in .tar file. See, test.tar. How do I know whether it is worked or not? It showed you it worked fine. Maybe test it. Let's move this test.tar to opt. Now untar it. Zip, unzip, tar, untar. Same thing. Tar hyphen cvf we gave, right? Xvf, extract the file. I extracted it. See the content. Is it present? Simple, right? So the content is there. Sorry, the content is there. I don't need it. So yeah. Now let's create tar again. Tar cvf. Just simple. It's nothing but a zip file. That's it. Zip file. That's it. So we created a tar file. We can compress it. We can compress it also. We can compress means like in of course zzip format. There is in zzip format here, which we can able to use it. Simple. It will be same command tar hyphen cvf like this, right? Sorry, cvf I gave. We can do something like cvzf. Z means zip. I mean, obviously it will use zip compression. Zzip. That's the name of the software. Oh wait. You know what I missed? I told to compress, but what is the file name? .zz. I need to give like this. So now this will create a file. See, obviously the size will be very less only, but generally if you have huge size, it will be like there will be a difference because .zz is compressing your content. If you want to compress, it's similar to how zip works. Zip, what happens is by default it will compress to you, but in tar not like that. Tar we are just creating a tar file out of multiple files and compressing it. So that's why what we do directly is we don't create we don't create first tar and we create a zip like that. We'll just use one command, which is this directly. So tar dot create a zip file along with the tar. So .tar.zz, this is the extension for us. Obviously it's created. Now how to extract it? Same thing, xvzf. cvf we tried, xvzf, that's it. Let's see. Wait. Now simple tar iphone xvzf. Sorry. Xvzf, that's it. As simple as that. It extract it. While extracting, we don't need to do anything, right? We don't need to pass the files or blah blah whatever it is. it's extracted. Obviously there is data. Let's remove all these data and try again. We've seen it, but yeah, let's see. All the data is gone except tar file xvzf extract. Of course, the data is present. That's how. That's how the command is. That's it. Just I told you, 2 3 commands only. Just we use this tar.zz rather than zip most commonly. Of course, we can use zip also. That also we'll see now. But we'll use this tar file most commonly. Tar commands. Tar hyphen cvzf xvzf. That's it. That's the only thing. Zip also we have. I think zip command exists. Oh, not there. So install zip. apt install zip. I'm using Ubuntu, so apt install. If you're using what is that? CentOS Red Hat, use yum. You already know it. So zip is installed. Now how to zip it? Simple. Zip hyphen r. Why I gave hyphen r recursively? Because there is a folder that we are going to do. We are going to zip it. That's why. Zip hyphen r test. Sorry. First thing you have to give the file name. Test.zip. And now the content test folder. One, two, it's zipped. How the hell I know? See, you can able to create a zip file also. It's completely fine. Obviously, how to unzip it? Unzip. What is the file name? Test.zip. Sorry, it's saying all the files already exist. Do you want to replace? Please replace it anyway. That's empty data. It's giving me one by one file name. Obviously, you know what I'm doing. So it's clear. That's over the zip. The only thing you have to do is in Windows you just do it by UI, but here there is no UI. You have to remember the command format, either tar or zip. Let's say tar or zip. Some arguments, whatever the arguments, like hyphen cvzf or hyphen r. Here destination and sources, multiple sources it can be. Destination has to be here. First destination means you have to give what file you are going to create. Tar file, right? You have to give like this test.tar.zz, or you are creating a zip file test.zip. You have to give the destination what you are going to create. Next is source. It means from what you are using to create that. You are creating zip file, but using what? Using these files, whatever. Give space, blah blah, give anything, no worries. That's it. That's how we use it. The format is same for both. Either tar or zip, the arguments we have to pass the destination next. I mean what you're going to create, and out of what you're going to create the destination, the sources, I mean the files or directories, whatever you want to yeah, sorry, whatever you want to from what you want to create, like folders, files, everything. That's about uh, zip also. Zip or tar, we can use these commands. We generally using this. Sometimes we download the tar files, we untar it and we use it. Sometimes we download the zip files, we zip them, blah blah. It depends on your use case. I mean, it's these are regular commands. I mean, I'm just wanted to show you. Got it? So that's about tar or zip. Next, there is a small topic I should have told you earlier, but yeah, I waited. So now, usually, have you ever wondered, have you ever thought what happens when we turn on a system? What all will start inside it? What are all inside? Like let's say I turned on my Linux machine or my Windows also. Let's say what happens? Of course, it will turn on. It will ask us the login page, or the screen. lock screen wallpaper, whatever is it. But what internally happens? I don't know about Windows how it happens. I mean, what and all. But in Linux, we have an idea of what happens. That what we call booting procedure. There are what happens step by step, so that we have an idea and we will see that. So we call it booting procedure. Yeah, this nice image we got. So this is the image I wanted to show you here. What's happening is this is what happens when you start a machine, Linux machine, starting from whatever it's showing. We'll see all those things. So now I am, I open my, Linux in my laptop. Let's say I opened it, and I just, oh shit. Yeah, sorry. I opened my laptop, and now what happened is I clicked on, the power button. Mine is a Linux laptop. So what happened? So what happens is these are all the steps it will happen. Let me save the image. Desktop. Okay. Hope we can see it now. Yeah. So it's fine. So these are all what happens. So now let's start take from first step. It says BIOS. BIOS means basic input output system. So it stands for basic input out. Okay, it's already there. Sorry. So what it does is it will perform some integrity checks, and there is something called a bootloader. Bootloader means how to say it. When you start a machine, I mean sorry, anything, any laptop, even let's say a Windows laptop, there will be a bootloader for that, which will trigger the booting process. Which will trigger the booting process. You might have seen something, press F12, something like that, randomly. All those things will be executed by bootloader. The bootloader will be stored actually in a disk, in your disk only, in your hard disk. But yeah, the first step, BIOS, when you turn on a laptop, I mean Windows, let's say Linux laptop in our case, BIOS will start, and this will execute bootloader. It says here MBR. What is it? MBR means master boot record, which is nothing but our, you know, that MBR which we have discussed, executing the bootloader program. So MBR is a bootloader program where it's usually stores. Where is it? Yeah, sir. Second step, it usually stores in our hard disk, XVDA or SDA version, right? It will store in this hard disk in the first sector of the hard disk. It means it will store at the starting of your hard disk. When you create a hard disk, when you create let's say you created a Linux operating system with 1 TB hard disk, what is the first thing to store in your hard disk is this MBR only, MBR and your operating system. So that's what it will be stored. I think it's not even 1 MB size, I guess, 512 bytes only, not even 1 MB size. So it has three things inside it. MBR has three things inside it. One is primary bootloader, which with the size is 446 bytes, and second is partition table. We have the partitions, you remember, right? Partitions. This partitions table will be loaded by this MBR only. That's why I always told keep in fstab file. etc fstab file is there to make it permanent mount. What happens is this MBR and all, this will read that fstab file, and whatever present inside, those things will be remounted when you start the server. If they are not present there, it won't care about it. That's why permanent mount is important. And third one here, I mean, I told three components. So one is primary bootloader, another is partition table, another is MBR validation check. So MBR validation check is for that. I mean, we don't do it for the boot record. It will validate it. So as I told you, it will be just 512 bytes. I think 512 bytes of size. Within the 512, it has three components. One is bootloader. It has 446 bytes. Another thing, partition table 64 bytes. MBR validation check is in 2 bytes. To keep it simple, MBR BIOS loads MBR, right? Executes MBR. MBR starts and it executes the grub. Grub stands for Grand Unified Bootloader. Sorry, this is the main one which will get started by MBR. I think now we are using grub 2. What it does, I mean, it's a bootloader actually. You remember we have slash boot. Let's go here. Sorry. See grub.cfg is configuration file, but remaining all we don't touch it. Never touch the grub. So this is a configuration file. But yeah, what it does, let's see it. Don't never touch the grub. I'm telling you, unless there is an issue, don't touch it. If grub is gone, system won't load. Grub, what happens is, sorry, what it'll do is not what happens. It's a bootloader actually. It's the main thing running here, which will execute the kernel. Oh, sorry, image. So it will execute the kernel. Kernel is of course the heart of the OS, right? Without kernel, we cannot start the operating system. Not even start it. It won't even start. I mean, not load or something. It won't even start. Even if you click on power button, if there is no kernel, nothing will happen. So grub executes those things. Grub stores the kernel images. If you have, like, let's say multiple operating system, you might have used it at some point of time. So in Windows laptop, you might have used Linux and Windows. You can switch it. Whenever at the time of restart, it will ask you which one to select. The page it will show you. Let me show you. See, like this, you might have seen this, or like this also you might have seen. Just like a different kernels, you have different operating systems, different kernels. Out of this, you can select which one you want. Like Ubuntu, some advanced Ubuntu, Windows, something, blah blah, something is there. It means your system has multiple operating systems. It means your system has multiple kernels. Of course, every operating system have a kernel, right? Like that, your system has multiple kernels. So grub will display that, because grub stores the kernel. I mean, it stores means it has information of kernel. It will show you, hey, which one you want to go. You can choose which one you want to go. If you don't choose, also there will be a default kernel, which grub will take automatically for I think there will be time or 30 seconds or something. So after 30 seconds, if you don't select anything, grub will take automatically, which the default one. If you choose it, grub will load that configuration file. If you choose, let's say I choose an Ubuntu on that. I have 5 things: Ubuntu, Windows, CentOS, blah blah blah. I choose an Ubuntu, so grub executes that shell. That's it, the kernel. Got it? Grub executes the kernel. So what grub have is, it has kernel which it will get executed based on your selection, whatever you selected. And there is something called initrd images. See here, initrd image. So here what's happening is, what is initrd image means, here related to kernel only. So initrd means init RAM disk. It's a temporary file system actually. So what happens is, it is temporary file system loaded into memory during the booting process, whatever it's happening, acting as a real file system. See, now until the system is start, we cannot access it, right? The hard disk, whatever the volumes and everything. So this initrd, I mean initial RAM disk, which will act as a temporary root file system. Why? Because we need to start the kernel needs to start, the kernel needs to load the files, all the configuration file, whatever it's present, blah blah, in this server, all the services, all these things, or that the volumes, the disk and everything, all these things will happen. So initrd helps in that. So to make it simple, grub executes, or starts the kernel, and it will execute the initrd images, which will act as a temporary file system for us. So That's about grub. This is a bootloader which executes the, which will show you what you want to, where you want to go. If you select, it will execute that image. If you don't select, it will execute default image. So grub 2 now we are using, I believe. So grub is a little old one. I mean, before grub there was something called Lilo, Lilo, Lilo. So like movie. So that Lilo is a bootloader. Now we don't use Lilo anymore. Even I think it's been 2016 or 15 somewhere they stopped it. I mean, so since then grub only they are using. I don't remember the year particularly, but yeah, I'm just guessing. So next, so grub executed kernel. Now what happens? What is the kernel does everything now, starting from mounting the root file system, whatever the not only the root file system, other other disks, whatever we have, other partitions, it will do all. It will execute all those things. And other thing it will start is init program. There's something, yeah, it's here has been init. Other thing it has is init program. What is init program is, I think I might have told you early yesterday. Init is the first process which will start when you start an operating system. That's why the PID is 1. pgrep init, let's see. What else? PS, let's say. PS, I'm just showing you all the things. Where is the init? Has been init somewhere, it will be there. Let's try like this. Up, maybe a different one. Let's see, somewhere it will be there. I think I've seen yesterday. Okay, user has been. Oh yeah, slash sb slash init. See the PID 1. So this is the first process. Now whatever the process you are seeing, all these things, all these are child process of this one, of this init. Child process of this init. Init is the first one which will get started by the kernel. So init gets started and it will start remaining things, whatever we told. I think just before we see it, enable the service. So init will do that. Init will do that. That we'll see in the next. So yeah, this kernel executes root file system and everything, and it will execute the init program. Init program means the init process or program. Both are same. The first process which starts in Linux. So that's why the PID is 1. It won't change. We cannot change. Of course, you cannot change the PID obviously. So yeah, that's what it does. Now next step, init. Obviously init is started. So the first program is started. Next what happens is, like, of course it'll start the remaining things, whatever required. And there is some file called init tab. Let me show you, sorry. Init.d, okay. Oh my god. Okay, now init tab does not exist, it's changed. Maybe I'm still following the old thing. Okay, that's fine. I'll check the file for now. Yeah, so this init, the program, where is it? It started, the kernel started the init, right? So now the init process, which it look for the configuration file based on what run levels, which run level we are using or which run level we gave, it will start system in that run level. We'll see what are those run levels, don't worry. See, there are 6 levels in Linux, 6 levels. Let me show you. Yeah, maybe this one. Anything but the run levels, there are 6. Okay, this is fine for now, temporarily. These run levels represent how you want to start your system. 0 means run level 0 means it's in shutdown mode. Run level 1 means single user mode. So only one user can log in at a time, and we cannot configure any networking part and all. We cannot start anything. We just log in, do some basic things, and we can get out of it. And run level 2 multi-user mode, we can configure networking, but uh, we can do something, but we cannot log in as a normal user. Run level 3, which is what we are using now, start the system normally without the UI. So this is what we are using, run level 3 so far. Run level 3, because run level 3 is something which we use the machine normally and without the UI. Run level 4 undefined. I mean, run level 4, no one using this run level. Nothing is present in run level 4. That's why it says not used undefined. Run level 5 is X11. It means UI. Ubuntu UI will be there. I mean, any Linux operating system UI. If you have an UI, if your server have an UI, it's running on run level 5. Run level 6 means reboot. It will restart your machine. So it just represent how we are using the Linux machine. We cannot, I mean, no, we can, but we don't need to change any of this. If you keep run level 0, it will shut down your machine. If you keep run level 6, it will restart your machine. If you keep run level 5, it will give you the UI, if we have installed configured. But of course, we don't have UI here because it's just a command line. So it won't work. We are using run level 3. Got it? So here what happens is like, it's just, as I told you, it represents what we are using, how we are using, simply let's say, how you are using the Linux machine. So these run level, there are 6 run levels, as you already seen it. Just type this command called who-r. It's showing run level 5 even though we don't have any UI. Of course, why? Because there are some things, let's say these colors and all, or green colors earlier we have shown, these are all does not come by default. So AWS have few color coding schemes installed. I mean, we haven't installed it, which we have installed. So that's why those things comes under run level 5. Run level command also can, it will show you level 5 like that. If you use pure run level 3, which is pure command line, it won't even show you these colors at all. Let's say blue color or red color it is showing, right? It won't show you all these at all. But for our understanding, like, I mean, AWS guys did like that, but that's why it's under run level 5. Even it's a basic, it comes under run level 5. If it's full UI also, it's run level 5 only. If no colors, nothing, run level 3 means same thing except you don't see colors at all. Just all are white like this. That's run level 3. So this init program executes the run levels. First it will find it. Which run level user defined. Of course, where I defined. As I told you, there will be a configuration file. I missed that somewhere. In that file, it's mentioned as run level 5 or 3 mostly, because 06 we don't use it. Where is it? Yeah, 06 we don't. It's restart shutdown. 1 2 we don't need. 1 I used even 1 or 2 times only, just when there is one issue I just logged in there, but that's it. Mostly 3 and 5. 4 of course there's nothing. 1 2 no, not really. So mostly 3 and 5. Either it will be 3 or it will be 5. So based on what run level is present in the configuration, this init, what it will do is it will execute all the things one by one, and it will execute this this run levels. First it will find out which run level the system is on, 3 or 5. As an example, let's say run level is on 5 in our case. So based on the run level, there will be configuration files. There is a folder called let me just go there. It is rc5.d, let's say. These are all the configuration files. See, so now what init does generally is, so it will execute the run level programs based on which run level. First, will identify, okay, system is running on run level 5. Now it will go to this folder. Of course, this is the old path, etc rc.d rc blah blah something. But new path is directly it's in etc only. rc5.d 3.dc 2.d 1.0 6 blah 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 all these things. So based on which run level, it will go to this directory and it will execute all these things whatever present in the directory. Got it? So let's say if it is run level 3, it will go here. Of course, as I told you, just a very basic UI we have. I mean, just for colors, that's it. So everything will be same, obviously. That's about it. That's about booting program, what it does. When you first start the system, you just click on a button, BIOS will start, which will execute the MBR, master boot record, and then MBR contains the grub, the bootloader. MBR contains the bootloader. So within the 512 MB, sorry, 512 bytes of size, this MBR executes the grub, which is bootloader. Bootloader executes the kernel based on your selection, or it will take the default one, and the kernel starts the init process and other root file system. So the init, which is the parent, the first process in Linux machine with the PID of 1, which will start the run levels. Run levels, the configuration files depends on what run level the system is running on, either 3 or 5 like that. And finally, once all run levels are executed, all these whatever it's present, it will show you the login page. If it is you're on run level 5 UI, complete UI. If you're on level 3, it will ask you same thing, username and password. Got it? So that's what happens. I mean, that's what happens when you turn on a Linux machine. Same thing, I think similar format will be there for Windows also. But of course, we don't need it. That's the only thing. Because we're working on Linux, we'll be working on Linux. So that's about the booting procedure. So far we have seen, like, today managing services with a system. 1 minute, sorry. Yeah. So managing services with systemctl, start, stop, restart. I think you all seen all this, and of course few basic commands, star and zip, and finally booting process. Why the booting process is required? See, nothing is required if it is not required. Everything is required. If your time is bad, you cannot see anything. But it's good to know what's happening, right? Even though, like, see, like, we are not learning for interview purpose, so we are learning for a knowledge purpose, right? So better to know these things. So that's what I'll say. So yeah, I think that same image present, I believe it's present in the PDF I shared, I guess, along with the description. I think it should be there. So yeah, go through that. Systemctl commands also there, but don't follow the systemctl commands from that. I think it's a little old one. The old commands will be present. Old does not work anymore. But yeah, tar remaining, you can try it. Just type systemctl command, it'll come directly. So don't worry. You don't need to ask anyone. Now AI is there, so ChatGPT or anything, you just open it, ask them, give me commands with a description, it will give you directly. So no need to worry about all those. Got it? That's about today's class. Any doubts? Anything and any questions today? And then we just have 4 more topics in Linux, maybe 5 more. So I think maybe by next week, by next, I think Friday, we'll close Linux. by next Friday, exactly by August 1st. We can maybe August 2nd or something. We can close it, and we'll go for DevOps. So yeah, anything, any questions so far? If no questions, we can close it. We'll meet tomorrow then. All right then. Yeah. Have a nice day. Bye.